Let's begin by reviewing the properties of exponents. First, we have multiplying like bases. We add the exponents. Dividing like bases, we subtract the exponents. When we have a power raised to a power, we multiply the exponents. When we have a quotient to a power, the power distributes to the numerator and to the denominator. When we have a quotient to a negative exponent, we take the reciprocal of the quotient and the power changes sign. Finally, whenever we have anything non-zero to the zero power, we get 1. Anything non-zero to the negative n power is equal to 1 over x to the n power. So we take the reciprocal and the exponent changes sign. So first of all, there is no new information in this section which is not in section 5.1. All of the properties of exponents, the exponential formulas, everything that we've seen before are exactly the same. The only difference in this particular section, we have more example problems. So suppose we have x to the negative 3 times x to the first. Well, we are multiplying like bases. So we can use the multiplying like bases formula, which means we add the exponents. So the exponent becomes negative 3 plus 1, which is negative 2. Since we cannot have negative exponents by the convention which the book adopts, we move the base from the numerator to the denominator and the exponent becomes positive. So our final answer is 1 over x squared. In this particular example, we are asked to simplify the quotient 4 to the second power divided by 4 to the negative first power. The thing that we notice is that we are actually dividing like bases. Since we're dividing like bases, we use the dividing like bases property, which means that we subtract the exponents. So we have 4 raised to the 2 minus a negative 1. But subtracting a negative is the same thing as adding. So our exponent is 2 plus 1, which makes it 3. Therefore, since this is a number, we can actually evaluate what it is. 4 to the third power is 4 times 4 times 4, and we get a final answer of 64. In this example, we have z raised to the negative 5 raised to the negative 9. Again, ignoring the fact that these are even negative exponents, we still apply the power to a power property. Using the power to a power formula, we know that we multiply the exponents, so that we have negative 5 times a negative 9 for the exponent. Well, negative 5 times negative 9 is positive 45. So our final answer, z to the 45th power. In the next example, suppose we are asked to simplify 3 to the negative first plus 4 squared, quantity raised to the 0 power. Well, this is a bit of a trick question because it doesn't matter how complicated the inside is. 3 to the negative 1 plus 4 squared is something that's non-zero, and anything non-zero to the 0 power is automatically 1. So no matter how complicated the base is, something non-zero to the 0 power is automatically 1. Suppose now that we have the quantity 3x squared y cubed raised to the negative 2 power. We see really that we've got a product of 3 things raised to a power. So we use the product to a power formula, and the power appears to distribute to each term in the product, so that we have 3 to the negative 2, x squared to the negative 2, and y cubed to the negative 2. Now we can apply the power to a power formula, so that we multiply the exponents, so that we have x raised to the 2 times negative 2, or x to the negative 4. we have y cubed raised to the negative 2. So 3 times negative 2 gives us y to the negative 6. Now we need to make all of the exponents positive. So if it's in the numerator, it goes to the denominator, and the exponent changes sign. So the 3 goes to the denominator and becomes 3 squared. X to the negative 4 goes to the denominator and becomes x to the 4th. And y to the negative 6 goes to the denominator and becomes y to the 6th. Now because the 3 squared is an actual number, we can simplify that to see what it actually is. 3 times 3 gives us 9. So our final answer, 1 over 9, x to the 4th, y to the 6th. Now we want to simplify the product 9x to the 5th times negative 3x to the negative 7th power. So we are really multiplying like bases. So we would add the exponents. So we've got 9 times negative 3 to give us a negative 27. X to the 5 plus a negative 7, which is the same thing as 5 minus a 7, which gives us x to the negative 2 power. Now because the exponent is negative, we can't leave that as an answer, so by our convention, the term with a negative exponent on it must switch from the numerator to the denominator, or from the denominator to the numerator. So in this case, the x to the negative 2, the x goes to the denominator, and the exponent changes sign. Now note that the 27, or the negative 27, doesn't change. It's in the numerator, and it stays in the numerator because the negative 2 is only attached to the x. It's not attached to the 27. So in this example, we want to simplify the quotient x to the 12th, y to the 5th, divided by y to the negative 3z, all of that raised to the negative 4 power. Well, we begin by simplifying the inside first. So notice that we've got a y in the numerator and a y in the denominator. So we can use the dividing like basis formula so that on the inside it becomes x to the 12th divided by z. So we subtract the exponents on the y, so it becomes 5 minus a negative 3, which is 5 plus 3. So on the inside we have y to the 8th power. And we still have all of this raised to the negative 4. So when we have y to the 8th, that y is in the numerator. So the inside becomes x to the 12th, y to the 8th divided by z, all of that raised to the negative 4 power. Now we can use the product and the quotient to a power formula so that we've got the product to a power. So the power distributes to each term in the product. The quotient to a power formula, the power distributes to the numerator and the denominator so that we have x to the 12th raised to the negative 4. We have y to the 8th raised to the negative 4. And we have z raised to the negative 4 power. Now continuing with that example, we have the power raised to a power formula. So we multiply the exponents. So we have 12 times 4, so we have x to the negative 48. We have y to the 8th raised to the negative 4. We multiply the exponents. 8 times negative 4 gives us y to the negative 32 power. And then we have z to the negative 4 in the denominator. So that according to our convention, when we want to switch, we want to make all of the exponents positive. If the base is in the numerator, it goes to the denominator and the exponent switches sign. If it's in the denominator, it goes to the numerator and then switches sign. So that we have x to the negative 48 goes to the denominator and becomes x to the 48. Y to the negative 32 goes to the denominator and becomes y to the 32nd. Z to the negative 4 in the denominator goes to the numerator and becomes z to the 4th. So our final answer, z to the 4th divided by x to the 48, y to the 32.